There we go. Okay. Awesome. So welcome everyone to this month's our January 1st meeting of the year for the Salt Lake City R user group. We are so happy that you're here. And we, I guess, have a tradition now for the past several years. Our first meeting of the year has been a session of lightning talks. And I always look forward to this session because it is fun to hear just a nice little like variety or smorgasbord of like different topics and packages and approaches and hearing just some of what folks are doing. So today, this is all folks who are here in the Salt Lake City area, and I'm always excited about to see what people are doing with R and data science, and it's really fun. So there are 5 talks today, and so these talks are going to be somewhere between 5 and 8 minutes long. I'll introduce each one, they'll give their talk, and then I'll introduce the next one, and we'll go through our 5 talks that way. I think we're going to hold questions for the end. Let's like hold the questions for all the speakers to the end, just to make sure we get through all these and give every speaker their chance to have share what they're doing. So if you have questions, certainly you can put them in the chat as they're going, and then we can come back to those at the end, or you can, of course, share your thoughts there at the very end. So I am really excited about our first talk. Our first talk is going to be from Byung-Yu. So Byung-Yu, do you want to? I'm doing this correct, right? Yes, yes. So if you want to get started sharing your screen. I will introduce just a little bit. So Byung-Yu has been living here, working for the Sorensen Impact Center at the U, and is going to be talking to us about developing more complex and advanced Shiny apps. So thank you so much, Byung-Yu.
Thank you, Julia, for giving me this opportunity. So as Julia just introduced, I was a data scientist at the Sorensen Impact Center located inside of the University of Utah. And I'm just transitioning to the other position in the University of Utah. So currently I'm a former member, but I just got admission that I can just present what we have achieved during the pandemic year, like 2 years, developing some kind of Shiny applications. So this is kind of more about stories about struggle and survival, even though I just said that we achieved kind of advanced Shiny UI and UX, but this story is about how the R and Shiny outperform Python-based web app tools and survive, and how to manage evolve on your data dashboard with a tons of customer requests, because this dashboard is not for the internal use. This is for more public use dashboard. In that account, we got a lot of customer feedback. Even at this moment, we are getting lots of emails and requests. So we have to address lots of requests from them. And also there are lots of technical challenges building up such a complex data dashboard using the Shiny. So at the former part, I will explain how we build up the dashboard. And the latter part, I will show up the real dashboard we just built up. So we just ended up developing three separate Shiny dashboard, and they are all about the higher education institutions in the US. So we mine the data set from the IPES, which is actually the government-based database. And we scroll the data set on the backend side of it and create such a more advanced data visualization with some statistical modeling. The first one we developed was a financial health indicator for the universities across the US. So we build up kind of an index. We can represent the financial health of each of higher education institutions. And the second one is more focused on equity data sets. So across different students' income or racial status, where we compare their performance inside of the university and across different institutions. And the last one, we've kind of build up kind of predictive models, how we, depending on the census data set, how we can project the future student enrollment across the US. So the first one, we focused first two for the financial health indicator and the equity dashboard. We focused on the data visualization of the existing data set. But the last one, we we try to accommodate more statistical modeling into the data dashboard. I will show up later. So the basic structure is like that. We use the Rhino package by Epsilon company, and we process the data using tidyverse and Arrow for the speed up, for the loading up, and for the data visualization. Well, we mostly focused on to accommodate the customer feedback. We use a high charter kind of JavaScript wrapper for the R, and the React table and FMTR for the advanced kind of a UI UX. And for the data modeling, we use a generalized adaptive models for the predictive modeling. And for the web app, we mostly rely on the Shiny Fluent, also from the Epsilon company, and also use a basic Shiny. For more advanced UI UX, we also code it a lot in the JavaScript and CSS and HTML. So this is kind of basic structure, how we build up the application. And I will highlight each of the packages we use. For the Rhino, because of the Rhino structure, which Rhino allows us to divide and conquer. So we can separate each of the modules, and many of different, like 3 or 4 different data engineers and scientists work together and collaborate more efficiently. So using the dependency, we imported the packages, and through the data plat, we gather all the data set we can collect, and we put them onto the app folder. Inside of the app folder, there are data and the logic. Inside of logic, we can load into lots of R script for the generalized additive modelings and JavaScript wrappers. And such a code will pipe into each of the tabs inside of the applications. And for the view folder, we create a separate R script for the, especially for the selector, because the Shiny app, for the user interface, we really focus on designing the selector, more efficient user experience. And we'll also use a high charter and UI functions and React table code in a separate folders. And they are all piped into the tab R script. Each of the tab have a separate R script files, and they are kind of piped into the data, logic, and view. So we could work really efficiently with the different 4 or 5 different members, but each of the members didn't collide in the GitHub because the Rhino could contain our separate each of the folders and files. So it was very convenient to collaborate each other with the Rhino platform. And for the high charter, the strength of the high charter package is that we can easily accommodate tooltip drill-down animation functions with that. And React table, it also have very strong boots for the animation, and also we could integrate lots of JavaScript and embedded tables and pops up. And that's almost same for the Shiny Fluent. It allows us lots of pops up and button options. So let me show you the real application here. Can you see the application?
Okay. Yep, sure can.
Yeah, the first one I can just show you is already, this is the equity dashboard. So you can select the state like Utah. And if it is public for a year, I will just, University of Utah, then it will show up the basic information of the selected university, like school profile and services. And from this moment, you will see lots of high charter based chart. And also you can see kind of different tabs on the left side. So this is still the high chart. And once you click each of the buttons, you can drill down into more detailed information time series of each of the informations here. So really convenient tool. And also you can see the comparison across different universities. I will select like Arizona State University. Once you click it, you can just compare across different retention rate for different universities like that. And the other one is a step application. Is it accommodates more advanced modeling like the GAM. So public 4-year-old Hispanic. This is a selector, you can use it. And once you launch it, you can see the map reacts, and also it displays what your choice looks like. And this is a high charter based projection models. So the dotted line is a future projection until 2030. And you can select or deselect and lots of different scenarios for the projection, even the breakdown into the census and also the enrollment and how different models indicate different trajectories. So this is how we ended up creating such a advanced visualization using the high charter and also the React table here. You can just, it's not yet complete. We are supposed to connect each of the button into the equity dashboard and financial health indicator dashboard. It's not yet, but this is based on the React table to provide more detailed information. I would just go back. Yeah.
Yeah, awesome. That is so cool to see. That is pretty impressive. Maybe do you wanna wrap up with one final thought?
Okay, I'll go jump into kind of challenges I had.
Yeah, thank you.
Yeah, there are lots of interchangeability and interactive issues across Shiny UI platform. For example, the Shiny Fluent is not yet accommodate kind of bookmark function. So I still have to rely on the basic Shiny to materialize the bookmark function. And also we got, as I said, we got a lot of customer feedback to improve the UI, especially the graphics. It requested us tons of work to do, and still we are improving for that. And the next challenges should be that integrating Quarto to create an automated reporting system, and also integrating the Python also for the better teamwork with the other members using the Python, and the connecting different apps and also scaling up. That's what next steps.
Awesome. Awesome, Byung-Yu. Thank you so much. It is amazing to see those Shiny apps. Wow, those are so detailed and complex, and it's really interesting to hear about like the challenges of doing that. Thank you so much, Byung-Yu.
Yeah, thank you.
Thank you. All right, so next we are going to have Joe talk to us about a package that he has been working on, which is about data analysis package. So thank you so much, Joe, for sharing your screen, and we'll have you unmute. Perfect, and start sharing with us. Thank you.
Great, thank you. So today I just have a few introductions about a package I've been working on, and also a desktop app version of the package. The app that I call it Starry, and it's kind of like rhymes with Shiny because it's built on Shiny, but packaged into a desktop app. So Starry is available in 2 formats. It's available as a desktop app, and you could download it on starry.app. And the Windows version is coming soon because I need to get it signed with the Windows Microsoft certificate. But the Apple version is verified by Apple and it's ready to download. At the moment, it's free for students and teachers, and I have a very open, liberal definition of students and teachers. So it doesn't have to be enrolled in a university or teaching at a university or school. You could, if you teach someone, you're a teacher. If you learn, you're a student. There are also paid plans for professionals, and that helps improve the package and contribute to development. There's also an open source package. You could install it from CRAN using the command installer packages Starry. So first I want to talk about the desktop application. So it's an interactive and notebook style application with an easy to use graphical user interface. It's beginner friendly. It aims to reduce the steep learning curve, especially for R and people for coming from Stata or SPSS and other GUI tools. It might be hard to start with a syntax-based environment. It comes pre-installed with R and also a lot of tidyverse packages, and it's completely local. Your data stays on your computer, so you could use it offline and you don't need to upload it anywhere. And you can create plots and tables using interactive widgets, and I have some demos coming up. And also you could generate and write R code This is good if you want to copy the code and go to RStudio or anywhere you use R, you could replicate your work there. You could also export your work from Starry in a form a .rds format. So these are some screenshots. It's a very minimal user interface. Hoping it's easier to use, but this is still in development, so please feel free to give some feedback. So I have a demonstration coming up. So as you could see, you could do tables and charts, and you could write code and it instantly prints out the output. You could write functions and execute them. And yeah, there are lots of possibilities. So here I can use an example data set, and I could even write markdown code. So you could like do a hashtag for heading and type some code, type some lines, and here you can look for a frequency. For example, so this is the penguins data set, and there are 3 species. So I could make a quick note. Then you can like do plots, like a scatter plot. You could choose variables, and this is a scatter plot, and you plot the regression line. But if you group it by species, the trend differs. So this is a interesting case of Simpson's paradox, and it's really easy to visualize and interact. And you could make plots like density plots, and you could facet it by 2 other variables, mostly categorical. So it's something like this. You could also do write some code like I talked about. So but I'm just going to copy some code here or write some for now. So easy and it's instant. There's a lot of errors that come up, but that's probably a feature. You could also toggle between an instant mode and like a run mode if you'd like to. You could also put some ggplots. Just very simple. So finally, you can save this if you'd like to, and then export it as an RDS file, which is an open file. You can use it in R even without Starry. So if you have someone you'd like to share and they don't want to download it, they can still open it in their R environment. So this, I just want to show you quickly, like you could import it back, and then it quickly runs all the functions. And also one cool feature is that you could actually see code as you use the options. So here you can see like what happens if you remove the fill argument, and you could see the changes very instant. It's easy, it's very helpful to learn R, especially with a lot of new functions and syntax. So yeah, there's still a lot of work to do. Planning to create more plot and stat modules and use different formats and release for Windows. But right now you could use the developer preview. It will show a smart screen, and if you say run anyway, you'd be able to install it. But in the future, I hope this works. I'm also going to talk a little bit about the Starry package. It's free and open source. You can use this command and install it. It provides similar functions like the app, but there are some limitations because of some limitations in Shiny. For example, if you lock your computer while running a Shiny app in Chrome, it might freeze and you may have to restart the app, and that sometimes breaks some systems. The package website documentation also available. And there are some functions I'm working on, but these are the ones we have right now. And I would just want to acknowledge the various packages and authors, contributors. Without these packages, it'd be impossible to make such a simple app. Particularly the Shiny and Tidyverse team have the infrastructure that I could build on. And also ggplot GUI, which is kind of an inspiration, and Jamovi, which is a similar environment. So yeah, you could feel free to download and try this and connect with me on LinkedIn or email me, and happy to talk about this. Thanks.
Thank you so much, Joe. That's so interesting. I'm just so curious. I'm going to break the rule and ask one question. So
Yeah.
is the app that you download and that you got like approved on the Apple's certificate
Yeah.
thing or whatever, is it literally a Shiny app?
Yes. So it's a
Wow,
Shiny
okay.
app that's running on top of Electron.
Okay, okay.
Yeah.
Yeah,
So,
that's
yeah.
so cool. That's so cool. Thank
Yeah.
you so much for sharing that. That's really interesting. And I think that like there's a lot of opportunity in that vein, right? Like people being able to make apps and release them for use more broadly. That's pretty cool. Awesome. Thank you, Joe, so much. That's very interesting. So next we have Bryant Chen. And Bryant, if you want to unmute and share your screen, that'd be super great. And so Bryant is going to be talk to us about constructing tolerance intervals, specifically non-parametric ones. So thank you so much, Bryant, for getting started.
Yeah. So my name is Bryant. I am a statistician for a defense contractor up at the Hill Air Force Base north of Salt Lake City. And I support the Air Force on various programs. And I'm going to be talking today about a topic that I had applied at work a few years ago, specifically tolerance intervals and more specifically non-parametric tolerance intervals. So this presentation is going to be a little bit more mathematical than some of the other ones, but I will be introducing a R package that will allow us to compute these tolerance intervals, and then how to do a simulation to ensure that the intervals have the stated level of confidence that we want them to. So introduction, just jumping into it. What is a tolerance interval? So a tolerance interval is basically an interval that bounds a specified proportion of the population from which the sample came from with a certain level of confidence. So we want that interval to be able to bound that proportion of the population a certain number of times. This is very different than, say, a confidence interval that you guys may be familiar with, where a confidence interval is with respect to the parameter of the population, like the mean or standard deviation, rate, whatever. But the tolerance interval, we're working solely with proportions. So that's really like the area under the curve for the population's distribution. This is pretty useful in, like, say, manufacturing environments where we want to determine like the specification, the spec limits for a product coming off of a manufacturing line. So how do we calculate these tolerance intervals? Well, there are a lot of methods out there for calculating them that are reliant on parametric assumptions. That is, that the population follows some particular distribution. And if you use these methods based off of these parametric assumptions, and if your population does not follow the distribution that you're assuming, then one of the consequences is a discrepancy between the stated level of confidence and what the interval actually covers. So what I mean is that the probability that the interval encapsulates the proportion is not going to be what you want it to be. So that's the main takeaway. So this sort of motivates non-parametric statistics, where we don't want to rely on these distribution assumptions. And there are a number of these different methods that fall under constructing non-parametric tolerance intervals. Some of them include Hahn-Meeker, Wilks, and Wald. The one that I'm going to be talking about today is Wilks, which is highlighted in red. So this slide is admittedly very convoluted, but I just want to highlight the main takeaway being that with Wilks' method, you're essentially taking your sample, you're sorting it from smallest to largest, and then you are taking the ranks. It could be the minimum and the maximum, or the second smallest, second largest, and you're taking those ranks and you're using the beta distribution to compute probabilities, and you basically are choosing ranks such that the CDF of the beta distribution will evaluated at the proportion of interest is going to be less than or equal to your significance level. So that's the main takeaway with Wilks method. It just utilizes order statistics, and a lot of non-parametric statistics rely on using the order statistics. Getting into the more practical side of things, there is a very handy dandy R package called tolerance that will allow us to compute these tolerance intervals. Will allow us to do parametric tolerance intervals as well as non-parametric ones. And these two main functions will allow us to do that. There are a number of arguments for each of these, where you can specify whether you want a two-sided or one-sided interval. What is the proportion of the population that you want to encapsulate, and what level of confidence, as well as the method. So with the non-parametric one, you can specify either Wilks, Wald, and the other one that I had mentioned in the previous slide. So we are moving on to a simulation where we can basically construct a population that could follow any sort of distribution. With this population, right, it's sort of like a mix between a normal and a log normal. And I've plotted the histogram of that population on the left, and then taking a sample from that population, we have the histogram of that sample on the right. The main takeaway is that this population is not necessarily normal. And we are going to compute tolerance intervals using the non-parametric method, which is Wilks, and a parametric method, which is specifically Howe's method, which is reliant on the population being a normal distribution. But as we know, since this is a simulation, the population is not actually normal. And we've computed the tolerance intervals using these two methods. And luckily, this package will allow you to plot out those tolerance limits, which are on the bottom. And I just wanted to quickly point out that on the first two lines, I have the sample from which the data is coming from the population sorted, just so you can see that the limits that were determined under Wilks method correspond to the second smallest and the second largest data points of the sample. Okay. And then moving on, we want to ensure that the interval has the stated level of confidence that we want it to. And we can easily see this by doing a simulation where we repeatedly sample from our population, get a sample, fit in a tolerance interval, and then see whether those limits of the tolerance interval capture at least, in this example, 90% of the population, with hopefully 90% confidence. And we can see, for the first, for the non-parametric method, we have a coverage of 93%, whereas with the parametric method, it kind of fell below what we wanted it to be, which was 90%. The actual confidence level, which we call the coverage probability, was 78%. So the main takeaway is that if you're using a parametric method for computing a tolerance interval and your population doesn't actually come from that distribution, then your level of confidence is going to fall below what you wanted it to be. And here's a plot that shows all of these intervals, with the left showcasing Wilks method, and that we have 93% of the intervals encapsulating at least 90% of the population, whereas on the right, it showcases Howe's method, which was reliant on the normal distribution, and us falling below the 90% confidence level that we wanted to. As you can see, it's about 78% of the intervals did that. And these are my references, and that's it.
Awesome. Thank you so much. By the way, you came in like right at 8 minutes. So like excellent job, Ryan.
Yeah.
No, so this is super interesting. And that last visualization that you made really hammered the point home. That's really interesting. Thank you so much for preparing that. Like something so practical and something like, yes, like intense in terms, not super intense, but like a lot of math, but also so practical. That's really great. Thank you so much, Bryant. We appreciate that a lot. All right. So our next talk is by Emily Robinson, and Emily might be a little, controversial here. Emily, Emma, I'm joking. I'm joking. Emily is going to be talking about how to use Python together with R. So thank you so much for joining us and for speaking.
Yes. Hi, everyone. I figured this might be a little controversial, of course, but I do want to talk about integrating Python into your R workflow. The original version of this talk was a longer keynote, which I'll link to at the end. And the longer keynote had at the beginning a little bit of some tweets sharing the thoughts of some R people on using Python, which I had to cut for time. But yes, I understand there might be some skepticism here. Even Python users are like, oh my gosh, I have to install Python on my new laptop, like out this laptop goes. So why might you want to use Python if you're already doing pretty well with R? Well, the first reason is that you may find it's a lot easier to use Python for a certain task. For example, I started using Python again when I was using AWS, and specifically, their SageMaker, which is a machine learning platform, and their Boto 3 package, which is like interfacing. So you can, for example, upload files to their storage system. AWS offers many packages in different languages, which kind of translate their API into that language. They do not offer one for R. They only do so for Python. And so in this case, I decided, all right, I actually gave a talk at this meetup on using R with AWS, but basically what AWS recommends, sort of the way to do it, is by calling Python functions from R, which I'll show how to do a little bit later in this talk. But maybe you want to go to Python directly, or at least you'll want to know how to access Python from R. You might use a tool that is a Python-based tool like Airflow. Maybe your colleagues are using Python. This might be the case. Let's say you join a new team, which is multilingual, but you want to be able to review your colleagues' code, or you need them to review your code, and they're working in Python. Or for example, my friend's Robert Chang at Airbnb, he wanted to switch from more analytics data science to machine learning within Airbnb. Analytics data science, you could use R. The machine learning teams all use Python. So he has a nice GitHub repo talking about how he went about systematically learning Python so we could transfer, and he did so successfully internally to this different team. Or in my case, I'm currently on the job market, and I am finding a lot of jobs that are data science jobs that are using Python. Finally, I really do believe multilingual data science is the future. If you were at our studio conference this summer, or you heard about it after, you might know our studio changed their name to Posit to better reflect how they're developing tools, not just for R, but for Python as well. Julia's team, for example, making MLOps tools, both in R and Python, or their professional products, which can be used by Python as well as R. All right, if you want to dip your toes into using Python, and then specifically maybe staying mostly within R, but using Python for some things, how can you do that? One of my favorite new tools is Quarto. There's going to be a whole talk on Quarto at this meetup in March, which is a very brief introduction if you're not familiar with it. It's sort of a next generation of R Markdown. R Markdown's not going away, but the idea of Quarto is it's not at its core an R package. It is a separate tool, although there's an R package interface with it. But it's the same idea where you can mix text and code and Markdown formatting to produce reports or dashboards or all different sorts of, or in this case, a presentation. It looks kind of like R Markdown. If you're familiar with it, you have these code chunks, you have some things at the top saying like the title, what kind of format, but there are little differences along the way. Like I said, I don't have time to go a lot into it, but there's a ton of resources, ton, especially from Posit, talks and blog posts and the Quarto website that I really recommend you check out. And like I said, this presentation actually is in Quarto. And it was, so all the code you'll see is, run the document. So in order to access Python code from R, there's the Reticulate package. The Reticulate package allows you first to set up a Python environment. So we can create a virtual environment, in this case called demo, where we can install some packages like that we might want to use, like scikit-learn or the Arrow package or SageMaker for AWS. And then we can say, let's use this Python package when we run Python code. You can pass data back and forth between R and Python. Let's say in R, I slightly modified the penguins data set to remove missing data. I can access that data set from Python using the syntax r dot. So r dot penguins.missing. And then in Python, I'm going to do some pandas to group by and take a mean and get the average bill length, a new data set. In R, I can access that Python data set using $, and we can see I can print out the head, the first 3 rows of that data set. You can also use functions from Python packages. Here's some Python code where I'm importing some packages for using interfacing with AWS, in this case with their storage system, in order to print out, okay, what's one of the buckets? Basically, buckets are folder. Let me see what's the first bucket I have, and that's dog rates. If I want to write this code within R, I can do that with the Reticulate package. And you can see the code's pretty similar. I run the Reticulate function import to get the sort of put in my namespace, the botto3. I can then access the functions from the botto3 package with this $. And I can print out and get the same result. Although, of course, what are the things going back and forth between languages, right? Python 0 index, R is 1 index. We can use models that we created in Python and R. So if I train a logistic regression model in Python to predict the sex of penguins, I can call that from R. Again, with this $sign syntax. So I say $, call train logistic regression model, run the predict function on this data set from Python, and fortunately get back the same answers. Before I leave you, I want to share this quote I really like from Ira Glass, which is about the tasteability gap. And he's talking about art, but it applies to code as well. And the fact of the matter is, especially if you're pretty experienced in R, when you start writing Python, you might be really frustrated that your code just doesn't seem that good. And, it disappoints you because you have these standards, you have these tastes. Or as Hadley Wickham says, the only way to write good code is to write tons of shitty code first. And if you feel shame about that bad code, it's going to stop you from getting to that good code. So if you're getting started, if you want to dip your toes into Python, give yourself some grace. It's okay that you're going to write bad or inefficient code, and that's how you get to the good code. Here are some resources. I don't have time to go through them, but there's some really nice resources. I especially recommend the Effective Pandas book because it's sort of like a dplyr way with chaining of writing pandas code. And there's tons and tons of domain specific books, basically for if you want to learn deep learning or, general machine learning, you can find books on that. With that, some of the links to things I do: I wrote a book, I do a podcast, I have a blog, I'm on social. And as I said, the slides I linked to, these are a longer version of this talk that I gave in November. So there's even some more details, some more reasons you might want to use Python or advice for getting started. But with that, thank you all so much for being here.
Thank you, Emily. That's super helpful. I know, so I'm definitely someone who my deep technical expertise is in R, but yeah, I work on a team now, right, where we both build R and Python software. And so this resonates so much in that both that what's helpful to actually do it and then how to kind of approach that. I don't know if you want to maybe drop those links to those slides from your keynote into the chat or something like that. That would be great. All right, this is super great. We're up to our last talk here. And so Greg, thank you so much for sharing your screen and getting started. I'm really looking forward to this because I'll be honest, I don't know what this word means. So Greg, I'm looking forward to you telling me what a nomogram is. So thank you for getting started. I can't quite hear you yet. There you are. Okay, perfect. Yeah. Thank you, Greg.
Sorry, I was muted. Can you see my screen now?
Yes, yes, absolutely. It looks great.
Okay. So Basically, this leads off a few months ago. We had a great presentation at Salt Lake City-RUG on visualizing logistic regression models. And I really liked it, but they missed what I thought was one of the great ones is nomograms. So this is an addition to what they've done. The nomograms can actually visualize regular regression and nonlinear regression, survival, other things in that, but I'm going to show for this. Basically, nomogram, they were first developed a long time ago. It's from the Greek for law and line. Basically, the original ones are a graphical tool for doing calculations by drawing a straight line. Using them for statistical models had kind of a brief popularity, like in the 90s when statisticians had computers, but our clients did not. Unfortunately, they've kind of been forgotten because most people will do their predictions just using the computer, but it's become a black box. But I'm trying to get them back being popular because I think they're still great for interpretation, even if you're not going to use them for the actual calculations. So as a quick example here, this is just using the NHANES data set. And here I did a quick logistic regression to see if I could predict if somebody's blood pressure was greater than 140, which is one of the definitions of high blood pressure. I modeled this using gender and a spline on age, the interaction between those, race and marital status. And so our summary comes out looking somewhat like this. With the drop one, we can see that race, marital status, and the gender age interaction are all very significant. When we look at the coefficients here, most of these aren't very meaningful, and even here these p-values don't look significant, even though the overall one is. And trying to interpret all of these directly is a little bit harder. So this is a nomogram based on that same model, or at least one very similar to it. And the idea behind the nomogram is that if we want to do a prediction, we look up those values here in the body of the graph, and then we trace up to these points here. So for example, if we were trying to predict for a 50-year-old male, so I'm going to come first to this male, since there's an interaction, I have a different line for males and females. I find 50 for males, and then I'm going to draw a line up to that top one and see we're about 70 points. I'm going to round off to make things easy. And this male happens to be Hispanic. And I'm just choosing some things, so that's up about 5 points. And we'll say has never been married. We draw up here, and that's about 10 points there. So to add those together, 70 plus 10 plus 5 is 85 points. So then we would come on this bottom scale, find the 85 points and draw down, and we see that this person we're predicting has just less than 20% chance of having high blood pressure. So that's how you use it if you're actually doing predictions. Now I'm going to make the predictions from the model or from the actual numbers. But if we look at this, some of the nice things we can see with this really quickly are, well, what's the nonlinear effect of age? So we can see for both males and females that, going from 20 to 25 gives us around 10 points. Going from 75 to 80 is down closer to 5 points. And so it's kind of a diminishing effect of age. We can see this age, as you get older, your risk is higher. It's just that it's not getting as much higher as we get up here. We can also see the interaction effect here in that, females start off with a lower risk, males with a higher risk. And we could actually even compare here and say, hey, look, a 35-year-old female has about the same risk as a 25-year-old male. We come over, as we keep coming, a 50-year-old female, slightly more risk than a 40-year-old male. But what's kind of interesting is from this model at around 60, they match up. And after that, the women actually have a little bit higher risk. The other big thing you can see with this is the race and marital status. We thought coefficients, but those were hard to interpret. But we can see that both race and marital status, while they were statistically significant, really have very small effect relative to age and sex. Okay, you know, the biggest difference in race is between whites and blacks, and that's still only about half of the difference between a 20-year-old female and a 20-year-old male. And even when we get up here, you know, the difference between whites and blacks here is still only about the same difference as between a 70-year-old and an 80-year-old. But we can see a lot of practical significance is these are the biggest, these are the smallest. I've done a few of these nomograms where I've had a term here, you know, all piled up here is the biggest difference was like 2 points on this 100-point scale. And so while it was statistically significant because I had really large sample size, it really made no practical difference. The things we can look at this and say, well, what does 10 points really mean? So, you know, being black versus white here is about 12 points. Never married is having a live-in partner is about, you know, 10 points. And so we can look here and say, well, if it takes me from 40 to 50, I'm only going from, you know, 1% to about 2%. Where it makes the biggest changes here around 0.5. So, you know, a 10-point increase takes me, you know, 100 to 110 is going from, you know, just below 40% to about 55%. So that is probably meaningful, but it's not huge, you know, compared to, you know, going from age, comparing a 20-year-old to a 50-year-old, you know, now we're looking at, you know, 50 points, which is going to be huge on here. So this is just, you know, another toolkit for kind of visualizing and getting a quick glance at practical significance in addition to the statistical significance, a way to visualize, you know, curved relationships and some of those simple interactions. So how do you make the nomograms? Well, currently the RMS package by Frank Harrell has a nomogram function. And also for the future, I am working on a package called R6 nomogram, which I'm hoping will be a little bit more flexible than this, have some improvements, but you know, Carol's works great. Mine, I'm hoping, gives you a little bit more flexibility. So watch for that in the future. I'm not sure when it will be hitting CRAN. I haven't even started on any documentation yet. So, and I'm done.
Awesome. Thank you so much. So what kind of models does it work with? Like could you use it with a random forest model, or is it like what do you know, just like generally kind of what the coverage
Yeah.
is?
So,
Is it
so
is it anything
currently,
that can predict, or does it use the model? Yeah.
so currently, yeah, is anything that the RMS package does, which
Okay.
includes regression, logistic regression, and that. One of the reasons I'm expanding it here is this R6 nomogram should work with anything that has a prediction function. You
Right.
know, if you can call predict on it, hopefully this will work.
Yeah.
So it'll work on all the same things here, but hopefully it'll easily expand to, you know, random forests and other things like
Yeah.
that.
Yeah.
Though nomograms aren't great for lots of complicated interactions
Okay.
with random forests
Right.
are there. So I don't know if
Yeah.
it'll help there,
Right.
but some of the other models.
Yeah. Yeah, that's so interesting. Thank you for sharing that. Yep, new to me. Never seen this before. So thank you so much for sharing that. Awesome. So I know we're coming up against the hour, but now would be a great time if anyone has any questions for any of our speakers. You can put them into chat, or if anyone has, yeah, a couple questions. We have just a couple minutes here before we're up against the end of the hour. I know I kind of broke the rules and asked my questions as I was going, so we can let other people do it too. All right, well, maybe we'll call that good for today. I just want to thank again so much these 5 speakers. These were great talks, super interesting. I really appreciate it a lot. Maybe we can maybe we'll call this the end of today, and we'll see you next time. So we can maybe stop streaming and recording, and then maybe if there are people who want to ask any questions, we can maybe stick around and Zoom a little bit longer. So thank you again so